Okay, let's take a look at this math problem. We have an optimization problem. The cost of fuel per kilometer for a truck traveling v kilometers per hour is given by the following equation. CV is equal to V over 150 plus 50 over V. Equation right there. What speed will result in the lowest fuel cost per kilometer? And then a second part, which if this video isn't too long, I'll do on this video. If not, I'll make a second part. Assume the driver is paid $53 per hour. What speed would give the lowest cost, including fuel and wages, for a 1,000 kilometer trip? Okay, so let's take a look. First of all, we're going to start with part A, and we have our equation. And whenever we're trying to find an optimization or a max-min question, we are going to have to take a derivative. In general, I recommend write everything out with exponents, and in here, by that I mean V over 150. Actually, let's rewrite that as 1 over 150 V plus 50 times V to the negative 1. So now we can just use our general power rule to take the derivative of the first. So the derivative of 1 over 50V just becomes 1 over 150. And then the negative exponent comes out front. And we get negative 150, or negative 50 V to the negative 2. Then we could rewrite that as 1 over 150 minus 50 over V squared. Okay, and we need to find our critical points. So now we need to find our critical points. And we do that by setting, we set C prime, the derivative, equal to 0, and we solve it. That's what essentially we have to do. So we're going to set this equal to 0. 1 over 150 minus 50 over V squared. Apologies for my V's. And here we could probably do this a bit faster, but just to make sure that we get all the steps in there, I'm going to bring the 1 over 150 to the other side. Both sides are negative, so if you just feel like dropping that negative sign as we go through, that's totally okay. We can cross multiply here. And then when we cross multiply, we get V squared is equal to 50 times 150, which ends up being V is equal to the square root. And here we're just looking at the positive square root, not the negative. We kind of jumped over the domain of this question. Normally it would be positive or negative. Under here is 7,500, which is about, that is, what is that now? That breaks down to 50 root 3. Won't bore you with the details on that. And then that's going to be about, for our human brains, 86.6, so about 87, and I'll just say 86.6 kilometers per hour. Now, to test, we're going to keep the exact value, 50 root 3, or we could do the square root of 750. Yeah, so I'd mentioned we skipped over the domain. The domain, we're just dealing in positives here. Once we see the graph, what the graph looks like, we can see that negative velocities will give us a negative cost, which doesn't make a whole lot of sense. So for our domain, I would say V is an element of the reals. And V has to be positive. Pardon me. All right, the question didn't really tell us to test it. Well, actually it does tell us to test it. So let's test it here. And there's two ways of doing that. We could use our first derivative test, first. So for our first derivative test, what we're going to do here, we're going to pick our intervals so we know. So we have our critical value here, so let's kind of write that out somewhere. Actually, I have it there. So V is equal to 50 root 3. That's our critical value. And for that, so we're going to need our intervals. So we're going to pick two intervals. Make a little table here. So our intervals are going to be from 0 all the way up to 50 root 3, which, keep in mind, that's about 87. I'll just about 87 kilometers per hour. Okay, and our second interval is from 50 root 3 all the way to infinity. We're going to want a test value. We're going to want to pick a value. So we know that's 87 whatever, so let's just pick 80 and 90. One above, one below. So that's our test value. We're going to take that and plug it into our original, not our original, our derivative. Okay, so we plug that into the derivative, and all we care here is whether it's positive or negative. So when we plug 80 into it, we get a very small negative number. I didn't even write it down, so we can just say that's negative. And when we put 90 into the derivative, we get a positive. And always remember, what does the derivative tell us? The derivative is the slope, so it's telling us how it changes. So if it's a negative slope, that means the original function, our CV, not our C prime V, is going to be decreasing. And when it's positive, it's going to be increasing. What does that mean? Well, we can see here, we can do a little diagram, and we can see that it's going to be going down, and then it's going to be going back up. What happens at the bottom of one of these? Well, that's going to be a minimum. So we could say, therefore, V is equal to about, we could say, we'd probably want to write it out a bit better here. So we'd want to say something like the speed that will result in the lowest fuel cost per kilometer is approximately 87 kilometers per hour. So we could say, therefore, min cost at V is equal to 87 kilometers an hour. So that's our first derivative test. Good way of doing it. Sometimes it's a bit longer, and so we can do our second derivative test, especially if the second derivative is easy to find. So our second derivative test, we need a second derivative. So we take our C double prime, and where we can take a look at, let's take a look at the original. Let's go from here, this highlighted, yellow highlighted. It's easier to take it from there. So we do that, the 1 over 150 goes away. We do our -2, bring that out front, the exponent out front. That gives us a positive 100. And then we subtract 1 away, so V to the -3, which is 100 over V cubed. So what we want to do here, we want to test our critical point. So we're going to put our critical point in C double prime of 50 root 3. Remember that 50 root 3 is just our 87. And really, so that's, yeah, let's write that out. 100 over 50 root 3 cubed. And the only thing that matters here is whether it's positive or negative. We're checking the concavity. That's another thing we could write down here. Second derivative test is we're checking for concavity. Concavity. Okay. And what we notice here is that it is going to be, I think it's only slightly positive. I did the calculation earlier. So it's going to be greater than 0. You could say, therefore, CV is concave up. C, so the actual value, C 50 root 3, is a minimum. And that would give you as much proof as you would need. Now, if you wanted a little bit more, you could always graph it. And the graph of this function is going to look something like this. And when you click on, this was made with Desmos, you'll see that right here. That's the minimum cost of that function, and it happens to be at about 87 kilometers per hour. I'm going to stop the video and do a second part for part B.